So hello friends, as we have discussed about the structural failures, we will extend the topic in this video. So on some aircrafts, it is specified that if no damages is found in primary areas, then the secondary areas do not need to be inspected. However, the precise inspection requirements vary from aircraft to aircraft. So the reference must be made to the appropriate maintenance manual, and it is important for the pilots to have a better understanding of fail-safe concept and the way it is designed in the modern aircrafts. The following is the summary of required relationship between the component failures, their effects, and the possibility of them happening as required by the certification specification maintained by EASA. Failures are classified into 5 main groups according to the severity of their effects. The lowest is the no safe effect. This is self-explanatory. It will happen with a no effect on the operation of aircraft. And next is the minor failure. This failure condition will significantly reduce the airplane's safety, but the crew actions required will be well within their capabilities. The third is the major failure. This will lead to the significant reduction in the safety margins or functional capabilities, a significant increase in the crew workload possible for the flight crew discomfort, and possibly the physical distress including injury to the passengers or cabin crew may happen. Another type is the hazardous failures, which will reduce the capability of plane or crew to cope up with the extent that there will be a large reduction in the safety margins. The conditions may be physically distress to the crew so that it is unable to perform the required tasks accurately. There may be some serious or fatal injuries to the passengers or cabin crew. And finally, the catastrophic failure will result in the multiple fatalities and probable hull loss. There is a summary for all these structural failure classifications, and we will spend more time to study it before we move on. Depending upon the severity of these structural failures, the distress and the physical injuries to the passengers or cabin crew may vary. And to study this safety margins, there are two possible failure conditions. First is the allowable likelihood of failure occurring is may be defined as both in the quantitative and qualitative way. A probable structural failure condition is expected to occur one or more times during an airplane's lifetime or less than 10 once in the 1000 flight hours. A remote failure condition is very unlikely to occur to each aeroplane or aircraft during its life, but it may occur several times when considering the life of a number of airplanes of same type, or it may be considered as less than 1 lakh flight hours. Extremely remote failure conditions are not expected to occur to each airplane type, but it may occur in a few times when considering the total life of the airplane. And extremely probable structural failure conditions are so unlikely that they are never expected to occur during the entire operational life of an aircraft. Nevertheless, it is also considered to occur once in every 1 million flight hours. To study in a more detailed way about the structural failure conditions, the simple rule is that the more severe the outcome of failure is, the less likely must be the possibility of it happening. As you can see from the chart, a catastrophic failure condition must be extremely improbable, where a minor failure condition may be probable. We spend more a moment of time studying this chart. It shows that dramatic view of the required failure and the severity of the failure condition. So as well as obeying these rules about the probability of failure conditions in the modern aircrafts, they are designed in such a way that the fail-safe concept is maintained. The basic objective to use is to achieve this to happen a single failure of a single element in the system or subsystem of an aircraft. This failure must not be catastrophic. A second failure in the same subsystem on the same flight should not be catastrophic unless and until it is joint probability with the first failure is extremely improbable. So, studying the structural failure conditions in order to achieve this fail-safe design concept, we use one or more viable designs of aircrafts subjected to the principles or techniques to ensure that the fail-safe design is maintained. The structural subsystems of aircrafts are tested for a proven reliability so that multiple independent failure conditions are unlikely to occur on the same flight. The airlines with large twin engine airplanes for extended range of operations have to continually monitor and prove their engine's reliability in order to allow to operate. So failure warning systems are provided for the crew to be aware of such failures. So in the coming session, we will discuss more about the forces and moments affecting the aircraft structures and how they compete or how they give the effects for the structural failures. Thank you for watching this video.